All right, today we are going to do a little flipped classroom session on section 3.6, compound inequalities. And we've been working on inequalities for a little bit now, and we are just kind of expanding on that knowledge today with compound inequalities. Essentially what a compound inequality is an inequality that consists of two distinct inequalities, all right? And these are usually joined by the following words. The words are and, or the word or. Okay, so I've given you two examples here. An inequality may say all real numbers greater than -2 less than 6. And what we're practicing today is being able to represent that, and eventually we'll solve some compound inequalities as well. All right, so if you think of what that means, greater than -2, less than -6 would be all values that are greater than -2. All right, and less than 6. So we've got open circles on -2 and 6, and what this inequality is representing all values that are in between here, all values that are from -2 to 6. So those values would include 0, 1, 2, and so on. All right. So this would be an inequality that would use the word and. Okay, because it is greater than 2 and less than 6. All right. An inequality that may use the word or could look something like this. If we minimize this and expand what we're dealing with this, all real numbers that are less than or equal to -4, or they are greater than -2. Okay, so if we wanted to graph that situation, all real numbers, let's break this down, less than or equal to -4. So values that are less than or equal to -4 would include these. Less than or equal to, so we've got a closed circle, and less than or equal to -4, those values would be going this way. Okay, or greater than 2, so we've got a greater than 2, meaning we've got an open circle on 2, and those values are actually all of these. Okay, so first thing is just being able to graph and represent these compound inequalities. Now, this would be pretty simple if this is all what we had to do, but we're also going to work on solving, which will be our next step. So, to solve a compound inequality, and we'll start with the ones that involve the word and. All right, this is kind of the way that these inequalities will be written. It's basically saying a number -4 is both less than -1, and it is also greater than or equal to -3. So the process that we go through to solve this is not much different than anything that we've worked with in the past. Really, all we're looking at here is we need to solve each inequality separately. All right, and as we talked about, to solve inequalities is very similar to how we solve equations. We just need to use those properties of equality, meaning that if we have some number -4, we would need to add 4. And in this inequality, we're actually going to add 4 to everything. Okay, kind of similar to equations. Whatever you do to one side, you've got to do to the other. And essentially, with this, we've got add 4 to each side of that inequality. What that will leave us with is a value of m is both less than, well, -1 plus 4, that is a +3, and greater than or equal to -3 plus 4, which is actually a +1. So the values that would satisfy this solution are all numbers in between 1 and 3. Now we will graph every single one of these. So let's just do that quickly. All right, let's say this was 0, 1, 2, 3. The values that are less than or equal to, or excuse me, greater than or equal to 1. Just got a closed dot on 1. Less than 3, so we've got an open circle on 3, and the values that make this a true statement are all values in between. So this is just a start on how to solve compound inequalities using the word and. Another one, and this would be a good opportunity for you to do this on your own. Okay, this one has gotten a little bit more complex. We've got a number plus 8 and then divided by 3. That number must be in between the values of 2 and 2/3. So let's take a look at this. X plus 8 divided by 3. The first step to solving a singular inequality like this would be to multiply each side by 3. So we're going to try and cancel off this 3 right here. Okay, we're going to try and cancel off that 3 by multiplying by 3 on both sides. From there, looks like if this was gone, because we times this by 3 as well, if that was gone, all we would have is x plus 8 on the inside is less than 2 times 3 or 6, and is also greater than or equal to 2/3 of 3, which is actually 2. And again, from there, it's pretty simple. We need to subtract 8 on each side, rewrite, and now we've got x by itself. X is less than, looks like -2, and it's greater than or equal to -6. And as with any inequality that we'll have here, we're going to graph each one. We draw that on our number line. We've got -6 here, let's say -4, -2. You don't have to be too elaborate with these graphs, but it is important that we see that the values must be greater than or equal to 6. We've got a closed circle, remember, and it's going that way, greater than or equal to, and it is also less than -2. So open circle on -2, and we've got all these values. Notice these are connected because these are the only solutions of that inequality. Let's move to the next type that we use. All right, more practice. If you'd like to try this on your own, you can definitely work it out. Okay, 4p minus 5. More practice with this, we would probably look to add 5 on both sides, solve it just like an equation, and we've got to do that to all sides of the inequality. We get 4p is less than or equal to 20 and greater than 8. So it looks like p must be less than or equal to 5 and greater than, divide by 4, looks like 2. All right, this would be the solution to that inequality. Again, you would need the entire thing. This would be our answer. All right. Now, what this is essentially saying, remember, this is an AND inequality, and we've got ANDs and we've got ORs. Okay. In an AND inequality, typically the graph will look like this, all right, with two values here and here and the values in between. In an OR inequality, it's going to be slightly different. Say we've got two values there and there. OR inequalities are typically going to look like this. All right, because it's one or the other, it's not both. Okay, so we'll get to one of those shortly. Compound inequalities with OR, what we do is we break down the two inequalities and solve each one separately. So essentially all you're doing is the same thing, you're just solving it separately. 6b minus 1 is less than -7, or 2b plus 1 is greater than 5. So we solve each one separately using the same concepts that we work with. 6 times b is equal to -6. Oh, excuse me, made a mistake there. Not equal to, this should be 6 times b is less than -6, and we divide by 6. Remember to watch out if we divide by a negative, the sign needs to flip. So b is then less than a -1, or if we solve over here, -1, -1, 2b is greater than 4, b must be greater than 2. Okay, so the graph of that, again, we've got a -1, let's go 0, 1, 2. The values that make this a true statement are all values of b that are less than -1, so we got our open circle going this way, or all values of b that are greater than 2. Okay, hope this was helpful. We'll see you in class.